We're moving on to a new topic today, well, picking up on an old topic really, and just doing a bit of revision on that today, getting going with it, reminding ourselves what it's all about. So we're looking at algebra, which is probably the most important topic in maths when it comes to building mathematical skills and looking at what you might be able to go on and do afterwards. So it opens up an awful lot of doors to other areas of maths and other areas of other subjects and careers and all sorts of things. Really, really important area of maths. So just first of all, remind ourselves what algebra is all about. All right, so the key thing, as it says over on the left-hand side of the screen, is about using letters to stand for numbers. That's basically what algebra is. We use letters to stand for numbers, and then we get various things that we can then do with that. So we've got letters in here that stand for numbers. Maybe this letter here, we see later on, has had a number take its place. We've got letters and numbers and things mixed in together. It's all about formulas. It's about equations, expressions, and terms. These will be other words that are associated with algebra. But basically, we come back to it's using letters to stand for numbers. So how is it so useful to us? Let's remind ourselves about that. Well, firstly, it's a lot faster and better at working things out. All right. So when you're younger, you learn that you can get to 24 maybe by counting in twos 12 times, going 2, 4, 6, 8, and so on. You can get there. But actually, it's much quicker to get to 24 by doing 2 times 12. All right. Multiplying is quicker than adding. And in the same sort of way, algebra can be quicker than using just number skills to work things out. It can help you to develop logical thinking, okay, because you're following a set of rules in order. So wherever you need to be logical about things, algebra helps with developing those skills around being able to process things logically. So it could be a logical argument in something like social studies, could be that kind of thing. But anything that involves logical thinking, algebra supports, because you have to be logical when you use algebra. It can help out in the real world. Probably if you ask most people, they'll say, I don't really use algebra at home every single day, and that's probably true of everybody, including me. But it can be helpful in some situations. It can help with planning around finances and those sorts of things. If you have decisions to make, you want to decide what's going to be the best for you. And as I was saying before, it helps with other subjects. It really opens them up. So if you want to study sciences further, if you want to get into medicine, become a doctor, go into statistics, look at engineering, architecture, or more advanced mathematics like calculus, then you do need to be good at algebra. Okay, it helps. It really opens them up. Without the algebra skills, those sorts of things become more difficult. And it helps us to prove things. Okay, some things we might think, well, we just know that they're true, all right? But proving is actually demonstrating that they must always be true, no matter what. And that's a very different thing than just convincing ourselves in our own minds that something's true. So as I've written here, if we take any two odd numbers and add them together, well, yeah, it seems reasonable that we get an even number. If I try anything, if I do 5 and 11, two odd numbers, I'll get 16. That's even. Okay? Pick really big ones. Does that work as well? All right, and it's quite easy to convince ourselves that that's true, but can we prove it? Can we show that no matter how big the number was, or how small the number was, this would always be true? All right, that's a very different thing, because there are an infinite number of actual number pairs to try, aren't there? You could choose any pair of odd numbers. To check them all, you're never going to be able to do. But algebra gives us a way of proving that this is correct, that this will always be true. All right, so it's really useful for that. And my final point on here is actually it's pretty beautiful. All right, this little picture that's just appeared there, that's a Mandelbrot set. Some of you might know about Mandelbrot sets already. You might have seen them in computing. And basically what it's illustrating is a solution to algebraic equation. All right, the algebra gives us this beautiful picture. Okay, so before we start, though, looking at stuff in general, we'll just remind ourselves that all the rules of addition, subtraction, multiplication, and division that we are used to using with numbers apply to algebra too. All right, all the rules about how we add, how we subtract, how we multiply, how we divide, they all apply to algebra too. Just because we're using letters instead of numbers, they all still apply to algebra as well. So that's helpful. And algebra skills are quite useful in cracking difficult problems and puzzles. All right, so the more you get into developing your skills, the more these more difficult problems and puzzles open themselves up to you in a way that they wouldn't do if you didn't have algebra skills to fall back on. Okay, if you're just using number crunching. So as an example, here's one, a kind of puzzle that algebra can really help you with. So we're told that the sum of three numbers is 231. If we add them together, we get 231. The third number is larger than the second number by the same amount that the second number is larger than the first number. It tells us what the first number is. Find the other two numbers. Now, there are ways of doing that without algebra, but algebra is much quicker at getting to the answer. Okay, and it helps us get there more easily. I'm not going to do that now, but that's just an illustration of the sort of thing that you could do. Some of you might want to have a look at that and might have a think about how you could use algebra to do that, but we'll maybe come back to that later on. Not in today's lesson, okay, but we'll come back to that later on maybe. All right, another sort of thing that this sort of thinking can help us with, solving a puzzle like this. So we've got buckets of chicken, we've got cats balancing, we've got bombs, and we've got that white box right up here. It's got two bombs resting on it, and it tells us there's some cats in there, but how many cats are in it? Okay, algebra can help us with things like that too. Again, I'm not going to do that right now. Reminding ourselves now just on certain words that we use to describe things in algebra, and some of these were on the first screen we looked at when we were looking at what algebra actually really is. So in blue here, this bit, we call that thing an expression. Okay, an expression is just something that has letters and numbers mixed in with it. Could just be letters as well, but basically we'll have letters and numbers mixed in it. Within an expression, they might be split up into different bits, and the bit in green here, just one of the three parts of the expression, the 9x, is called a term. If we go a little bit further and we look at the black box, the black box has an expression on the left and an expression on the right, and there is an equal sign between them. So we've got an expression equal to another expression. That is called an equation. Whenever we see something with an equal sign in algebra, that is an equation. Okay, we have that. And then other things that we sometimes talk about, we talk about variables. Variables are our letters that stand for numbers. So there's a variable, there's a variable, there's a variable. There are just three variables in this equation because the letter x appears twice. You could argue there are two because x appears twice, count it once. But there are three places where variables appear. You've got the two places where the x appears and the one place the m appears. They're the variables. They can take number values. They are the letters that we use in the algebra. If we have something, a term that doesn't have a letter in it, we call that a constant. It's just a number. It does not change. It can't take other values, whereas m here can take other values. This is a constant. It doesn't change. It's just a number. And if we have a number in front of a variable, in front of a letter, that's called a coefficient. All right, so these are words that we'll use. The important one for today is expression. That's what we're going to be looking at. All right, but just thinking about these coefficients here. Here we've got a coefficient of 52. Here we've got a coefficient of 9. But here we've got a constant of 36. Okay, so they're useful words when it comes to describing things that we see in algebra. Okay, so we're going to look at writing expressions. That's what we said we're just going to remind ourselves about today. And we're going to start by just looking at a particular example. So I'm going to let the letter x is going to be my variable, and that is going to stand for my age now. And I want to write an expression that uses x, so an expression that's going to have x's in it. X's are going to be the variables in there, for what my age would be next year. My age today is x. Can I write down an expression, something with x's in it, that will describe what my age is, what my age would be next year? Well, if I think about my age generally, what do I have to do to find my age next year? Well, if you think about your ages now, what do you have to do to your age to get your age next year? Don't you just add 1? So my age next year, as an expression, would just be x plus 1. What my age is today, x, add on 1 to take me to the next year. What would be my age in 5 years' time? Well, again, think about if I know my age today, whatever it is, how do I work out my age in 5 years' time? Well, I take my age today, which is X, and I add 5 to it. Add 5 to my age today, remember X is my age today, and I get my age in 5 years' time. What about in Y years' time? So we've introduced another variable here. Y could be anything. So we know what we have to do. That's coming back up here. We know what we have to do. That's my pointer, which happens a lot. We know we have to do for 1 year. We add 1. For 5 years, we add 5. What's going to happen in Y years' time then? Well, we're just going to add whatever the value of Y was. So it will be my age today plus the number of years that I want to move it forward. My age in Y years' time will be X plus Y. Okay, if it was 1 year, it's X plus 1. If it's 5 years, it's X plus 5. If it's Y years, it's X plus Y. All right, Y could take any value. So that could tell me in 99 years' time. If I'm still around, probably not, unfortunately. But if it was in 99 years' time, it'd be X plus 99. What about 1 year ago? So I know my age today is X. What do I have to do to that to get my age last year? I take 1 away. Take 1 away from my age today, and I get my age last year. All right, so what about Z years ago? All right, Z is a new variable we brought in here. How do I do that? Well, I'm going to have to do subtract away that number of years. All right, if Z was 2, I'd do X minus 2. If it was 2 years ago, if it was 5 years ago, I'd do X minus 5. If it was 99 years ago, I wasn't born, so it doesn't really make a lot of sense. But if it was 40 years ago, yep, I was around then, that would be X minus 40. Okay, so we just take away the number of years. 2W years ago is now what we're thinking about. Well, again, it's just some number of years ago. All right, 2W is just going to be a number. All right, so that could stand for anything I like. It's just going to be a number. So just as we did last time, it's that many years ago, I would just take away 2W from my age today. Okay, so that's how we can start to think about it. Sometimes it's easier to work with numbers to start with. Yeah, you're probably thinking that one, and that one are quite easy because they've got numbers involved in them. But when we start to bring in other variables like the Y, like the Z, and like with the 2W here, okay, we're going to have to think about that a little bit more. But we've got the same things happening. All right, if it's a number of years further on, we're adding the Y. If it's a number of years ago, we're subtracting the Z, we're subtracting the 2W. Right, let's have another look at a different example then. So we've got a number of students in the class. We are told to start off with here, there are N students in the class. Okay, and we want to write expressions for the number of students in the class if 2 boys leave. So we know we started with N students in the class, 2 boys left. So how do I work out how many students are left? There are now N minus 2. We had to take 2 away from the number of students we had in the class to start with. That's what's happened. They've now gone. How many students are in the year group if there are 4 times as many in the year as there were in the class originally? Okay, so we've got to look for those were in the class originally. Originally, there were N students in the class. We are now told there are 4 times as many in the year. So you might think, okay, we need to do 4 times as many as there were in the year. And that would be correct. You might also have said, well, I take the number that were in the class to start with and just times it by 4. That would also be correct. But hopefully you're remembering that in algebra, we don't write times signs. One of the reasons being is it can be confusing. Are we talking about a times or are we talking about an X as a letter? So we decide the rule is that we don't write times signs in algebra. If we write 2 things next to each other, that means times. So here my 4n means 4 times n, or n times 4. The number, though, always goes at the front. Always write the number at the front. All right, we never write n4. Always 4n. Always the number at the front. Okay, so n4, although what you might think is saying the same sort of thing, because we've just said we don't write times signs in algebra, we never write that. Okay, we will always write the number before the letter. All right, part C. How many girls are in the class if half the class were originally girls? All right, so we think again. Here's the number originally in the class, but half of them were originally girls. Well, if I divide the number that were originally in the class by 2, that is going to tell me how many girls there were in the class, isn't it? All right, for 20 in the class originally and half were girls, divide by 2, get 10. But again, we don't write divide signs in algebra. Like we don't write time signs in algebra, we would either write it like this, n divided by 2. Remember, that's a fraction. Looks like a fraction, doesn't it? And a fraction is a division. So we either write it like that, n divided by 2, or if you wanted to, we sometimes would just say, well, it's a half of n. All right, so we make it into a times, really. Half of n. Half times n. Remember, number and then letter means times. Either of those two would be acceptable as the answer. How many students are in the class if m more students join after the 2 boys left? Right, so after the 2 boys left, how many students were in the class? There were this many. But now we've had m more students join. So the number of students has gone up. If there were 3 more students join, we'd add 3 to that, wouldn't we? If there were 5 more students join, we'd add 5 to that. So we've got to add the number of students who've joined. So n minus 2 plus m would be fine there. And how many girls are in the class if p girls then leave? So if we assume that we've still got our half n for the girls, but p girls then leave, to be completely sure that actually it was still half n there, I mean, if I'd have said m more boys, that would have made it really clear, wouldn't it? We know we've still got half n girls left in that class. The girl number hasn't been affected. So half n were the number of girls we did have in the class at that point. P girls have left. Well, if 1 girl left, we'd take 1. If 2 girls left, we'd take 2. If 5 girls left, we'd take 5. We've got to take away P, because P girls have left. Right, question at the bottom. It says, can you write an expression for the number of students in the school if there are 15 times as many as are now in the class? Now this gets tricky. This is, really high-end thinking we've got here. We need to think how many are in the class now. All right, so how many students are in the class altogether? If we can do that, we need to do 15 times it. So we know before those P girls left, we had this many students in the class. All right, those M boys joined after 2 boys left. But now we know that P girls also left. So actually in our class now, this is how many students there are. And we are told there are 15 times as many as that in the whole class. Well, we know, if we look at part B, we know that we can just times by the number more that we want. We'd have to times this number by 15. All right, we'd have to do 15 times by that. We know in algebra we don't write times signs. But I need to do 15 times all of this. All right, let me just bring my pointer in. 15 times all of this. And this is where remembering that all the rules that apply to numbers also apply to algebra. We need to do this bit first before we multiply by the 15. How do we indicate we do something first? Thinking about BIDMAS. we do brackets around it. And that then would be our answer. What's this telling us to do? Take the number in the class originally, subtract 2, add on the number of extra boys who joined, take away the number of girls who left, and then times all of that by 15. No times sign there, remember, because we don't write times signs in algebra, but work out the bracket and then times all of it by 15. That is tricky, all right? If you follow that bit, you're doing incredibly well, but that's a bit trickier. Okay, so a couple of questions on the screen here. I want you to see if you could have a think about. So this is one of those points where you pause the video and have a go. So you've got a question about minibuses and coaches. You've got a question about cakes and lollies. Okay, can you answer those 2 parts about minibuses and coaches and those 3 parts about cakes and lollies? So pause the video now, have a go, come back in a minute, or as long as it takes. Okay, so we're back. Let's have a look at where we've got to then. So we have this first question. We've got minibuses have got 12 seats, and we've got coaches have got 48 seats. Write an expression in terms of M for the total number of seats that would be in M minibuses. Well, if we had 2 minibuses, we'd have 2 lots of the 12. If we had 3 minibuses, we'd have 3 lots of the 12. So we can say that what we end up having to do is times the number of minibuses by 12. And to write that simply in algebra, remember, without any times sign, we'd write 12m, because that means 12 times m. For part B, it's now saying, okay, well, we want the total number of seats now that there are in M minibuses, well, we know what that is, and C coaches. So we've got to add on the number of seats that are in C coaches. Each coach has got 48 seats, so we do 48 times C. Okay, 12m plus 48c. Let's look at Jennifer and Paul and their cakes. So Jennifer made C cakes and put 4 lollies on the top of each cake. We need in part A to know how many lollies she used in total. Well, each cake has got 4 lollies. If I had 2 cakes, I know I'd do 4 times 2. If I had 5 cakes, I know I'd do 4 times 5. I've got to do 4 times the number of cakes that she made. 4 times the number of cakes that she made will give me the number of lollies that she's used. Let's look at Paul. Paul made 12 more cakes than Jennifer. Well, here's the number of cakes that Jennifer made. Paul made 12 more. Add 12. How many lollies did Paul use? Well, Paul, we're told, put 5 lollies on the top of each of his cakes. So this is how many cakes he's got. We know if we times the number of cakes by 5, we'll get the number of lollies he used. Okay, if he made 12 cakes, we'd have to times that by 5. If he made 20 cakes, we'd have to times that by 5 to work out the number of lollies he's used. But remember, we have to work out the number of cakes he's made first, do the C plus 12, work out that first, and then times by 5. Okay? So remember, if you think back to numbers, it can often make it easier. Take it a step at a time. Even write down some of the things with numbers to start with. It might help you. You know, if I'd have said with, coming back to Jennifer here, if she'd made 5 cakes, okay, I could have started to think about it a bit and even written this down to help me, then that would be 4 times 5 lollies. Yeah? Don't work out what the answers are, because what we're trying to do is see the pattern. What calculation are we having to do? And we're having to do 4 times the number of cakes that she made. So we'll have to do 4 times C. All right, that can be helpful.